In this video, we're going to do 2 more questions using the chain rule. So looking at our first one here, I have f of x equals the square root of 4x squared plus 6x minus 1. Now, before I can do the derivative of this, I need to rewrite my expression using powers. So I don't want the square root. I want to try to write the square root as an exponent to make this easier. So f of x, this isn't the derivative, we're just rewriting this in a slightly different format, is going to be 4x squared plus 6x minus 1, and then a square root is the power of 1/2. Okay, now that I've written it as a power or a bracket with a power, I am going to use the chain rule. How do I know that I need to use the chain rule? I have a bracket with an exponent on the outside. So to do my derivative, we're doing f prime of x. We're going to start with what's inside that bracket. So we're going to take the derivative of 4x squared plus 6x minus 1. So that we're just using the power rule for. So we do 2 times 4, which is 8x, right? I take 1 off of that exponent. 6x, the derivative of 6x is 6, right? There's a secret exponent of 1. 1 times 6 is 6. And then if I take 1 off there, that's x to the 0. And then negative 1, a number, the derivative of a number is always just 0. So I have 8x plus 6, that's the derivative of what's inside the bracket. And then I do the whole function. So we're going to do 1/2 times the coefficient. There isn't anything there, so it's just a half. And then times 4x squared plus 6x minus 1. And then I have to take 1 off of that half, which I'm going to say is negative 1/2, and then I will show you in case you're unsure of how I got that number. So I do 1/2, take away 1. I need a common denominator. That color does not show up very well. Let's try red instead. Okay, that 1 is secretly 1/1. I need a common denominator, so we're going to go with a denominator of 2. So we're doing 1/2 minus, I would multiply top and bottom by 2, so that's 2/2. So 1 minus 2 is negative 1, and then the denominator stays the same over 2. Okay, from here, there's a couple of things I want to do, right? I can see that this bracket can be factored further, and it did say it was supposed to be in factored form. I also notice that I have that fractional exponent, and I want my answer to match the original question. So the original question was given as a root, so my final answer should be written as a root. I also notice that I have a negative exponent, so we are going to try to deal with that as well. But first, I'm going to start by factoring this bracket. So I have f prime of x. They both divide by 2, so this is 2 times 4x plus 3. And then times 1/2, and then we'll deal with this part in a minute. So 4x squared plus 6x minus 1 to the negative 1/2. I do have 2 constants. We have the 2 and the 1/2. I can multiply those together. So 2 times 1/2 is just 1, right? Or 2/2, which is 1. So I would have 1 and then 4x plus 3. I don't have to write the 1. I am going to write it in. So I have 1 times 4x plus 3. Now I'm going to tackle at least the negative part of this exponent. A negative exponent makes a fraction. So it's going to take this bracket and it's going to push it down into the denominator. So this is going to become 4x squared plus 6x minus 1 to the 1/2. So it's not negative anymore, it's just 1/2. And then that 1/2 is square root. So this is going to be f prime of x is, I don't really need the 1, so I'm just going to say this is 4x plus 3 divided by, and then that is the square root of 4x squared plus 6x minus 1. So in order to take the derivative, we had to write it as a power. we did the derivative with it as a power, and then we tried to put it back as a root in the end. And because we ended up with a negative exponent, it also ended up being a fraction. All right, well, there's my final answer. We've got one more example to go. So our next one says f of x is 10 over, or divided by, 4x minus 15 to the power of 3. So same situation as here, right? I don't currently know what to do with fractions. So we haven't really talked about how do I take the derivative of something when the variables are in the denominator, but I can use a negative exponent to get that up into the numerator so that I can take the derivative using the chain rule that we just talked about. So I'm going to rewrite this as f of x equals, there's still a 10, and then I want to bring the 4x minus 15 up out of that denominator. When I do that, I need to use a negative exponent, right? Negative exponents make fractions, so if we're trying to pull something up out of the denominator, we need to use a negative exponent for that. Okay, the derivative. So f prime of x. We start with the bracket. So that 4x minus 15. We're going to take the derivative of that. The derivative of 4x is just 4. And the derivative of 15, which is a number, is just 0. So that's actually just 4. And then we do the whole function together. So I'm going to do negative 3 times 10. That is negative 30. And then 4x minus 15. And I need to take 1 off of that exponent. It's already negative. So if I do negative 3, take away 1, that's going to give me negative 4 as my exponent. Okay, I'm going to multiply these two numbers together. They're monomials, so they're single terms, so I can put those together. 4 times 30, negative 30, is negative 120. And then because the original was a fraction, if I have a negative exponent, I should write my final answer as a fraction. If the original question had a negative exponent, you're welcome to leave it with a negative exponent. So I am going to bring this down into my denominator and say it is 4x minus 15 to the power of 4. And there's my derivative. All right, go work on your homework.